All right, lesson number 2 for Unit 9. Still working with polygons. What we're going to be working with today is area formulas. It says triangles and quadrilaterals, but we're going to do triangles, rectangles, parallelograms, trapezoids, rhombus, such as a square and a kite. And I'm also going to add in the area of a circle, even though that's not a polygon, but we're going to include it for a couple of the problems that we're doing. So triangle, area equals 1/2 base times height. So I'll just write the B equals base, H equals height. Hopefully this is one that we're pretty familiar with already, or you can think of it as base times height divided by 2, same thing. Rectangle, length times width, length times width. So side by side. A square, the same formula works, but since the side lengths of a square are the same, you can do side squared. A parallelogram. This works for a rectangle, square, and rhombus. Area equals base times height. So remember, this is what a parallelogram looks like. Technically a square, rectangle, rhombus, those are all parallelograms. But if we're given the height for something like this, and then we're given the base, which would be from here to here, or from here to here. Okay? And then this would be our height. This would be the base. Now, trapezoid. Trapezoids can be a little bit trickier. The formula for these, once you practice it enough, it's not too bad. It's just a little different. So here we have a trapezoid. Remember, a trapezoid has one set of parallel sides. So B1 and B2. B1 stands for base 1. B2 stands for base 2. These are the two parallel sides that we're looking at. So here's my B1 and here's my B2. It doesn't matter which way you organize them. What we're going to do is we're going to add those two together first. That's what's in parentheses. And then you multiply that by 1/2. So it's finding the average of the bases, and then it's multiplying by the height. So here is our height, distance from base 1 to base 2. So yeah, in words, you take the average of the bases and then multiply by the height. Now our rhombus, this works for a square and a kite. You're going to multiply the diagonal lengths and take half of this product. So D1 is for diagonal 1, D2 is for diagonal 2. And remember, the diagonals are like the cross sections. So I'll show you in an example here as well. Find the area of a given circle. Now this wasn't listed before. Area of a circle is pi times r squared, where r is the radius, and you can use 3.14. So we know what our radius is, it's 9. So pi times 9 squared. Oop, hold on one second. Okay, so pi times 9 squared, so pi is 3.14 if you want to plug that in, or you can find the button in your calculator, times 81. If we type this in, 81 times pi, we get 254.47. And that would be inches squared. Whenever we're doing area, we should put our units squared. Now we have area of a square, pretty straightforward. 8 times 8, or 8 squared, gives us 64, and that's inches squared. Here we have a couple more. We have a rectangle, and then we have a rhombus. So the area of this rectangle, now this one's a little bit different. You're going to see some problems like this on your worksheet, where you're given the area, but you are missing one of the lengths. So like the height, the width, the whatever it might be. So here we know the area is 144, and we know the formula is area equals length times width. So here we're missing the width. That's our x. So we're just going to replace this 144, and we're going to plug it into the area. So 144, we're going to say the length is 16, and then this is x. If we wanted to get x by itself, we would divide by 16. And if you take 144 divided by 16, we get 9. So x equals 9 centimeters. This time we weren't trying to find the area, we were just trying to use the area to find missing pieces. Here, the area is 24 centimeters squared. We have a rhombus. Diagonal 1, it doesn't matter if it's the vertical diagonal or the horizontal. I'm just going to say that that's our vertical one, so this one right here, and then this is going to be our horizontal diagonal. So the area formula for diamond or a rhombus is 1/2 and a kite. 1/2 diagonal 1 times diagonal 2, which is x. This time what we need to do is replace the a with 24, but we need to get rid of that 1/2 first. So let's actually multiply both sides by 2, because that's how you would get rid of the 1/2. So 48 equals, now on the right side we have 8x, because this is going to go away with our 2 over here. Then we divide by 8, and we get x equals 6. So there's just going to be some back solving with a lot of these problems. I'm actually going to go, yeah, that's the end of our notes for this section. I'm going to go to the worksheet and just look at a couple things, give you guys some hints on a couple problems. All right, so here you're going to fill out all of the formulas, which I had listed before. Then you're just going to calculate the area for these different shapes. Hopefully that's not too bad. Number 5, 6, and 7, this is going to be problems like what I was just showing you, where you're given the area, but you have to find the missing pieces. This is not showing up super well, I apologize. Number 8, you got to use, I'm going to give you a hint. It says you have to calculate the height, the dash segment, in order to calculate the area. To do this, you need to use trigonometry. So the image is not appearing very well, but for number 8, you have to use a trig function to solve for the height. And then these here, the shaded region ones. So I'm going to do number 1 with you. Let me pull it up here. All right, so number 1 of the shaded regions. We have a circle, and it wants us to calculate the area of the shaded region in each diagram below. So for this circle, we have technically 2 different circles. We have this inner circle, which is 11 meters with its radius, and then the outer circle is 4 meters extended onto that, so technically the big circle is 15. But if we want to find just the shaded region, what we can do is figure out what is the area of the big circle, what's the area of the small circle, and then just subtract them. Okay, so remember area equals pi times r squared. So for this, pi times 11 squared is going to give us 121 pi, because 11 squared is 121, and then I'm just going to call that A1 for the small circle, and then A2 is going to be 11 squared times, or not 11 squared, excuse me, 15 squared, because it's the bigger circle, which is going to give us 225 pi. Okay, so if we take the big area, 225 pi, and we minus the smaller area, when you type this into your calculator, there's 2 ways you can do it. You can go ahead and type in 225 pi, enter, minus 121 pi, enter, or you can actually just leave them together as they are. So if you take 225 minus 121, you get 104 pi, and then we just change pi to 3.14. And we get 326.56 meters squared. That is the area of that outer shaded region. Okay, so that's what you're going to have to do for those other problems. Probably use different formulas, though I had to use a circle formula. If you have any questions or issues, please let me know. But hopefully a lot of this is just review from area lessons you've learned in the past.